I've got the 1/8 holes all drilled up to 3/16 now, all the way through. I missed a couple here because they're really close. And once the drill bit starts to break through into the hole next to it, the web of the drill bit, or the flute of the drill bit actually grabs and it wants to bind. So I've actually gone ahead and I've grabbed this drill. This is it's a 3000 RPM drill, but unlike this guy, which is a third of a horsepower, this one is half a horsepower. So I've got a little bit more gusto with the larger drill bit going through this material. And again, drill bits aren't intended to cut sideways, but that's what I'm doing here, and splitting these webs open. So it's not too good for the drill bit. You've got to be really careful that you don't put too much pressure on it, and just let it go slowly and cut as it will. You don't want to snap the drill bit, because then you get into things flying around and eyeballs getting hurt and such. So I'm going to move the camera and I'll show you what I'm doing here. Probably better to have a little bit of a close-up to see exactly how I move that drill bit. So as you can see, I've already got a little bit of it done. I am going to go ahead and put a little bit more lubricant on that drill bit just to help it cut. I'm getting close to that bronze bushing. I'm not trying too hard right now, but I'm getting as close as I can without contacting it too much. So I insert the drill bit into a hole and fly side load on a drill bit. Big negative. These ones are pretty deep, so you might have to do it in 2 stages like that. So there's no downwards pressure in this scenario, just bad pressure. Little bit of pressure, open her up. She's moving slowly. Oh, look at that. So much the same as the last one. The bushing is still on there. You can see we pecked into it a bit, but not too bad. Yeah, that relieved a lot of pressure on this guy. Doesn't look like, oh, I'm wrong. Looks like that penetrant got in there about a quarter of the way around anyway. Hadn't been there for long, so that's good. So a lot of corrosion in that. And that is our blade root. I'll have to get those out later. They're in there pretty good. Not bad. It was broken already though. And that's that guy. So obviously no good. This bungee's for you, Tom White. Tom is a sheet metal guy on the Jet Age Museum Typhoon project, and he likes to bug me about my bungee cords on rivet guns. Before I get too carried away with chain wrenches and levers and cheater bars and stuff over there trying to get that thing to twist, I figured the best thing to do is to clamp it down. The vise isn't big enough. That was the easiest solution. So because that's not going to work, I just happen to be working on a T-slot table. So I've got some T-slots, and I just need to make a clamping bar that'll fit across and span the spider. And then I'll clamp it down, and leverage will be a lot more useful in that regard. I guess more of the effort will go into the part. Same with any of the impact and hammering that I'm doing. It'll really, if it's clamped down securely, it'll help direct more energy, and it might just be that little bit more. So I'll try that first. Anyway, so I'm just over working on a clamping bar, and it's just a piece of angle iron that I had. So I'm going to drill the 2 holes in it for the 2 bars or 2 rods that are coming out of the T-slots, and unfortunately I need a 5/8 drill bit, and everything I do is aviation, and 5/8 is pretty rare. I think I've got a 9/16, but that's not going to cut the mustard. So I've got a 5/8 chatterless countersink, and I've done this a couple times before. It's definitely not the right thing to do, but it's what I have to get this done and make that work. So I've got a couple of them, so if I need to sacrifice it, I will. But here it is here, and I've got to put it in a bigger drill because of the diameter. But yeah, I'll put a lot of cutting lube on it, and I'll blast through. I've piloted both of those holes as a 3/16, and now we'll just blast through with that countersink. So it's a little bit bush. It's definitely more expensive than a drill bit, but like I say, it's what I got. So here we go. Okay guys, so with the holes drilled in that, I've now, I hope you can see that, I've now rounded the corners. I took a bit of an edge off the back, just a little bit of deburring. Better safe than sorry. That stuff's sharp, and if you swing at it with your arm, it hurts quite a bit. I've also cut a piece of aluminum to cover the spider, just where that clamp is going to go. A little bit more protection so it doesn't cause any marring of the surface of the spider. Again, just to preserve whatever we can. I've also grabbed the T-bolts, and I needed to make an extension, so I've got the bolts themselves extended by 1, as you can see here. And I've grabbed these guys too, the normal clamps used with this set, and I think I'm just going to throw them on top. If they fit, I'll throw them on top to help prevent a little bit of the flex in the this piece of angle iron. It's only 3/16 material, so if I load it up too much, I don't want it to bow. Okay, so taper pin router bits. Let's go. I don't think I'm going to weld up a wrench. I don't think that's working out. So I'm going to go ahead and cut from the bottom of one of these tangs in. I have the other one, so I know how deep it is. It's a tapered thickness, which makes it difficult. But I'm going to cut from this area here that's the thickest and see if we can relieve a little bit of pressure in there. I'm going to do that with this, which is a tapered router bit. There are 3 flutes, and they're meant for side cutting. Just because they're meant for side cutting doesn't mean that they don't break. They break all the time. They're fairly high consumable when you're doing stuff, especially on thick material like this. that moving, guys? It looks like it's moved to me. That's moving. So there's that bushing. Not too shabby. Let me just get a rag. Ooh, that bushing was hot. Okay, take those guys off. Those are those plates again. I believe that one's a shim and this one is a permanent fixture, but that's depending on when you're setting up the prop. I think that's where that guy comes into play. So with that off, I'll have to take this and soak it. I'll talk to Carl because he mentioned that they soaked a bunch of stuff in molasses, and I hear that works well for steel anyway, and with very closely monitored times. I do know that molasses will destroy magnesium, like most things will, and it's not good for aluminum either, so I wouldn't try and remove corrosion with that. But my understanding is that it does do some good stuff for steel, and I think this would look quite a bit different once cleaned up, so we'll give that a shot. Thanks for watching, guys. That's that took a little bit more work than the last one, but I got it off, and I got it off without having any kind of marking on the spokes for the spider, so quite pleased with that. The surface underneath looks good. It was worth the effort. Now we've got it ready to clean up, and that can happen slowly over the next couple of weeks. And we'll move on to the next stuff. I'm hoping for the next episode to just run you through the finishing touches on our fuselage frames. They're complete now. I just need to go through them and verify them. I'll do any planishing or cleanup work that needs doing, and possibly some marking and stamping and labeling. And I'd like to get those off ASAP for heat treatment so we can start assembling that monocoque structure. Thank you so much for following along, guys. Please subscribe to our YouTube channel if you can, and to our page channel if you can as well. Every penny goes towards the airworthy rebuild of Hawker Typhoon JP843. Take care, guys. Cheers.